Assalamu alaikum, my name is Imin Shafiq and welcome back to AutoWorks Pakistan. So in today's video, we will talk about oxygen sensors or AFR sensors. But before moving forward toward the details of oxygen sensor, first of all, we should know why we need to know about the oxygen sensor. This is because this sensor is responsible for maintaining the fuel efficiency of your car. In Pakistan as well as in other countries, we are facing a problem related to poor fuel economy, and one of the cause can be a bad oxygen sensor. This is because this sensor is located in the exhaust manifold of your car, which means it is prone to failure and frequent problems. Even if the trouble code is not generated, this sensor still can be lazy and have a massive drop in the fuel economy of your car. So in today's video, we will talk about the construction, its working principle, how we are supposed to clean our oxygen sensor, what are the symptoms of a bad oxygen sensor, and in the end of the video, we will talk about how to test an oxygen sensor with the help of our modern diagnostic tools. Then moving forward toward the introduction. So starting from the introduction. These sensors are also called Lambda sensors, as these sensors are responsible for measuring the correct amount of oxygen in the exhaust manifold. It then communicates with ECU and helps it to figure out the correct amount of air-fuel ratio for the engine's best performance by telling it whether your mixture is rich or lean. It also tells the efficiency of our catalytic converter. So if you're having more content of oxygen, that means your mixture is lean. But if you are having less content of oxygen, that means your mixture is rich. We will discuss this in detail later. Now, the types of oxygen sensors, and there are two basic variants of oxygen sensor. First one is narrowband and the other one is wideband. The narrowband have a voltage range from 0.1 to 0.9 volts, and it will give a perfect air-fuel ratio, which is 14.7:1 at 0.45 volts. The other type of sensor is wideband oxygen sensors, which are used in modern cars, and they are usually known as air-fuel sensors. These sensors have a wider range of voltage from 0 to 5 volts, and it will give a perfect air-fuel ratio, which is 14.7:1 at 3.3 volts. Now moving forward toward the location. So this is what happens inside your car. This is our intake manifold, injectors, this is our engine, this is our exhaust manifold. Here comes then upstream oxygen sensors, then catalytic converter and downstream oxygen sensors. So basically there are two oxygen sensors located in your car body. So what happens, and when the high temperature and high pressure air passes through the exhaust manifold, the upstream oxygen sensor measures the presence of unburned oxygen in the exhaust manifold. The air then moves through the catalytic converter and then through the downstream oxygen sensor, and the downstream oxygen sensor measures the performance of catalytic converter. For example, if both of these sensors are having same value, that means your catalytic converter is not working properly. Now I'll talk about the construction and working principle of oxygen sensors in detail. So this is a typical narrowband oxygen sensor, and this is how it is placed inside our exhaust manifold. These are its drilled holes that are provided at the tip of this oxygen sensor, and it is really important to understand what happens inside this oxygen sensor. So here we will discuss the construction and working principle. This is its main body, and a layer of zirconium dioxide is provided in the main body. Heater core is placed between the zirconium dioxide, and the air passage is provided between the heater core. So what happens is, when a high temperature, high pressure air passes through the exhaust manifold, at the same time the atmospheric air is allowed to enter the air passage, and the heater core will heat that air up. Now the concentration of oxygen in the air passage is higher than the concentration of oxygen in the exhaust manifold, that initiate the process of ionization in zirconium dioxide, and the electron will start moving from the higher concentration toward the lower concentration and induces a voltage in the sensing element that descend the information toward the ECU, and it generates a voltage like this. Now we will talk about some of the characteristics of AFR sensors. So if you are testing your sensors with the help of any modern diagnostic tool, you should know the waveforms. So if you are testing your AFR sensor, because AFR sensor is kind of different from a narrowband sensor, you'll have this kind of waveform. So at 3.3, if your AFR sensor is correct or perfect, it will give a waveform like this at 3.3 volt. But if it will give the waveform like this, below 3.3 volt, that means your mixture is rich, and if it's above 3.3 volts, that like this, your mixture is lean. But if you are testing a narrow band oxygen sensor, which are different from wide band oxygen sensor, the waveform should be sinusoidal like this, from 0.1 to 0.9 volt. And you can also check whether your sensor is lazy or not. It should oscillate 10 times in 8 seconds. If you are having an ideal or perfect oxygen sensor, that means it will give a AFR ratio 14.7:1, lambda value which is 1, and the current draw by that sensor will be 0. Now we will talk about the difference between the oxygen sensor and the AFR sensor. These two sensors are different in the sense that oxygen sensors tells the ECU whether you are having a rich mixture or lean mixture, while the AFR sensor not only tells you are having a rich or lean mixture, but it also tells how far it is from ideal mix. Like most of the cars in Pakistan are non-EFI. So how we are supposed to check their air-fuel ratio? So we can use this AFR sensor along with this AFR dial, and we will mount that sensor in the exhaust manifold of the car, and we can constantly monitor the AFR ratio and other parameters with the help of this AFR dial. Now we'll talk about how to clean our oxygen sensor. It is important to make sure that you are using an O2 cleaner in order to clean your oxygen sensor. And other thing is that we are not only supposed to clean the tip of oxygen sensor, because some of the deposit can be in this part. So what we are supposed to do, we put this oxygen sensor in a vibrating chamber, and it will, with the help of that vibration, it will remove the deposit inside this sensing element. So with the help of that, we can perfectly clean a old oxygen sensor or a lazy oxygen sensor. Then I will talk about some of the symptoms of a bad oxygen sensor, how you are supposed to know that you are having a faulty oxygen sensor. Check engine light, engine will lack its power, engine missing problem, or black smoke. Other than that, your car will lose 40% of its efficiency. Now we'll talk about some of the main error codes of the oxygen sensor. First one is P0101, that means your mixture is lean. P0175, your mixture is rich. And P0714, fuel trim malfunction.
So O2 sensor is the most important sensor that plays a pivotal role in maintaining cars' fuel economy. So it is mounted in exhaust. So ये 600 degrees पे ऑपरेट हो रहा होता है. तो ज़्यादातर जो सेंसर्स हमारी गाड़ी में ख़राब होते हैं उसमें से O2 सेंसर एक बहुत कॉमन सेंसर है. तो आज इस वीडियो में हम अपने सोफिस्टिकेटेड डायग्नोस्टिक टूल्स के ज़रिए आप टेस्ट करके बताएंगे कि किस तरह आप अपने O2 सेंसर को टेस्ट कर सकते हैं. सो जो 3 मेन पैरामीटर्स हैं जिससे हम O2 सेंसर को चेक करते हैं वो ये हैं. सो फर्स्ट वन इज़ इट्स लैम्डा वैल्यू, इट शुड बी इक्वल टू 1 और ये फ्लक्चुएट होनी चाहिए फ्रॉम 0.99 to 1. और second one is voltage, it should be 3.3 volts, and the third one is current. If your sensor is perfect, then it should draw 0 amps.